So in this video we're going to solve a quadratic equation by completing the square when the leading coefficient is not a 1 to begin with. So use the technique of completing the square to solve the quadratic by the square root property. So we're going to go ahead and rewrite the original equation, negative 3x squared plus 1 equals 4x. And just like before, I want to get the constant terms over on the right hand side. And I want everything with an x in it on the left hand side. So my first move is going to be to subtract this 1 from both sides. And then once I've done that, I'm going to subtract the 4x from both sides. So what I'll wind up with is negative 3x squared minus 4x equals negative 1. And then what we brought up in the previous video is that the completing the square technique requires that the leading coefficient on the x squared term be a 1. And in this case I see that it is not a 1. So the next step is to get a leading coefficient of 1. And I'm going to do that by dividing by the leading coefficient. In fact, I'm going to divide everything on both sides by the leading coefficient. So whatever you do to one side, you do to the other. So if I divide everything on the left by negative 3, I'm going to divide everything on the right by negative 3 as well. So I get a negative 1 divided by negative 3 is positive 1/3. The expectation in the homework is that you'll work with the fractions and not try to convert anything into decimal approximations. We have negative 3 divided by negative 3 is 1, so I get 1x squared. There's the leading coefficient of 1 I needed. And here I have a negative being divided by a negative. It's going to give me a positive. And I have 4/3 x. And then what we want to remember is that with the completing the square process, we take the coefficient on the x variable, the linear variable, the x to the first variable. We take that coefficient and we need to have it. And there's two ways we can have a 4/3. We could divide it by 2, creating a complex fraction, or we can realize that dividing by 2 is the same as multiplying by a half. If we have a 6 and divide by 2, we get 3. But if we have a 6 and we multiply it by a half, we also get 3. So in this case, because my middle coefficient is a fraction, it's going to be easier to multiply by a half than dividing that fraction by a 2 and causing a complex fraction. So we want half of this middle coefficient, but once we get half of it, we need to square it. So 4/3 times a half is going to simplify to 2/3, which we need to square. And then when we square this, we get 2 squared is 4, and we get 3 squared is a 9. So 4/9 is what we're going to add to the left-hand side to complete the square. And whatever we do to one side, we need to do it to both sides. So now I've completed the square on the left-hand side, and I need to say whose square have I completed? Well, it's going to be x, and then it's going to be whatever half this middle coefficient was. So this was a plus 4/3, and when I halved the plus 4/3, I got a positive or plus 2/3. So I'm going to go x plus 2/3, and if I square the number 2/3, I should get the 4/9. Right? If I square the 2/3, I get the 4/9. So 2/3 squared is the 4/9. Here I need a common denominator, so 9 is going to be the common denominator. So if I find a common denominator, I'm going to have a 7/9 when I add these two together. Maybe I'll give myself a little space here. This is a 7/9. And in this step, I want to realize I have an algebraic expression squared equal to a positive real number. So I can use the square root property to get the x out of the parentheses. I take the square root of the left-hand side to cancel the squaring. And whatever I do to one side, I do to the other. And because I'm doing the square root property, I recognize that there are two numbers that when squared will give us 7/9. It's going to be plus the square root of 7/9 and minus the square root of 7/9. And I need to put that plus or minus the moment that I do it. So now I can start to simplify. I have plus or minus. The square root of 7 is already in simplified radical form over The square root of 9, I know it. The 9's in the denominator position, so the square root of 9 is 3 in the denominator position. The square root canceled the squaring, which drops out the x plus 2/3. And now I need to subtract this 2/3 from both sides. So when I do that, I'm going to get negative 2/3 plus or minus the square root of 7 over 3. And there's my two solutions. There's one solution, two solutions. If I put it in set notation, I would say x is an element of the set that contains negative 2/3 minus the square root of 7 over 3, comma, and I get negative 2/3, and I get plus the square root of 7 over 3. And you could write this even a little bit more compactly if you wanted to. You could recognize that the denominators are the same. We could actually write this as negative 2 minus the square root of 7 over the common denominator of 3, comma, negative 2 plus the square root of 7 all over the common denominator of 3 would be another way that we could write this.